Here is the example and the diagram for the same. In some cases, they will not provide you the diagram. In that case, you need to draw the diagram. Okay, for as per the problem statement. Now, just we will discuss solution for that particular problem. Now, what is the given data? D, that is capital D is 1.5 meter. Okay, that D is the diameter of that particular pulley. Okay, it is already given 1.5 meter. So radius is 0.75 meter. Okay, T1 is 5.4 kilometer. That is tight slide. That is tight side. Okay, tight side of that particular bed, which is of 5,400 Newton. Okay, T2 is the slack slide, 1.8 kilometer. That is 1,800 Newton. Length is of 400 mm. Okay, and shear stress is 42 MPa. Okay, 42 Newton per mm square. So all these things are given. Okay, length is length from the bearing. Okay, here you can see the bearing, and 400 mm is the distance from that particular pulley. Okay, okay. So now we will solve the problem. So now we know that the torque transmitted by the shaft. Okay, the torque which is transmitted by the shaft, that is T is equal to T1 minus T2 into R. Now, how to find out T1? When there is a belt tension is there in that particular pulley. So total torque is equal to, that is tight side minus slack slide into radius of that particular pulley. That is T1 minus T2 into R. Okay. So already we know the value. T1 is equal to 5,400 minus T2 is equal to 1,800 into a radius is of 0.75 meter. Okay. Okay, so here we get 2,700 Newton meter. That is the torque. Okay, the torque which is transmitted by that shaft. Okay, in such type of cases, in case of a belt, you need to use this formula to find out the torque. That is tight slide minus slack slide into radius of that particular pulley. That is T1 minus T2 into R. So 2,700 Newton meter is the torque which is transmitted by that particular shaft. Okay. So 2700 into 10 raised to 3 Newton mm. Just we are converted into meter into mm. So that's why you need to multiply 10 raised to 3 Newton mm. Okay. Now neglecting the weight of the shaft. Okay. Now neglecting the weight of the shaft. Total vertical load which is acting on the pulley. Now we have to find out total vertical load. Okay. But here you need to neglect the weight of the shaft. Okay. So how to find out? So W is equal to, so that is total load which is acting on the pulley. This is nothing but T1 plus T2. It is the addition of T1 plus T2. So 5,400 plus 1,800 is equal to 7,200 Newton. That is the weight vertical load which is acting on that particular pulley. Here we have not considered the weight of the shaft. Okay, because it is not given. So here you can neglect the weight of the shaft, but you can find out the load which is acting on that particular pulley. Okay, are you getting this, all of you? Yes, Tushar, Ubale, Adesh, Kumbhar, are you getting this? Ankush, Chetan, Anishwar, Gaurav, Kunal, Pramod, Pranav, Rishikesh, Ritvik, Saurabh, Shoaib. Are you getting this? Yes, okay. So all the things are given in a problem statement. Just we are just tabulating all the things. Okay. So first we need to find out the torque, then the how much load is acting on that particular pulley. Okay. So the simple things are there. Okay. Okay. Now the bending moment. Okay. Now the bending moment is nothing but M is equal to W load on that particular pulley into the perpendicular distance. Okay. So how much will be the W? 7,200, that is load, into length is 400. So 2880 into 10 raised to 3 Newton M. That will be the bending moment of that particular that diagram. Okay. Okay. Now we will go ahead. Now our main intention is to find out the diameter. Find the diameter of the shaft. Okay. So all the inputs they have given you, and according to you need to find out the diameter, because finding of the diameter is the most important in case of a shaft. Okay. Okay. So now we know that the equivalent twisting moment. Okay. Equivalent twisting moment, that is T, equivalent twisting moment, TE is equal to square root of m square plus t square. Okay. Already we have seen that formula. Okay. But in terms of, we have seen m square plus mt square. Okay. That mt is nothing but the twisting moment or torque. Already I have told you. So just directly you can write m square plus t square. Yeah, m is nothing but the bending moment and t is nothing but the torque. Okay. So just I will put the values. M bending moment 2880 into 10 raised to 3 bracket square plus torque that we have got 2700 into 10 raised to 3 bracket square. So here equivalent torque you will get 3950 into 10 raised to 3 Newton mm. Okay. Okay. So we also know that the equivalent twisting moment TE is equal to pi by 16 into tau into dq. So all these formulas we have already seen. Okay. So TE is equal to pi by 16 into tau into dq. किंवा आपण याच्या आधी फॉर्म्युला असा पाहिला tau is equal to 16 upon pi 16 upon pi d cube into that TE, that is square root of m square plus d square. हाच फॉर्म्युला फक्त इथं काय केलं डायरेक्टली TE is equal to pi by 6. ओके, हा फॉर्म्युला आपण ऑलरेडी पाहिलेला आहे. जस्ट यू कॅन क्रॉस चेक द फॉर्म्युला. सेम फॉर्म्युला वी आर गोइंग टू यूज. Now just all of you do the calculation and find out the diameter. Shear stress value is already given. How much it is? That shear stress value tau is 42 Newton per mm square. Okay, now just put that 42 Newton per mm square in that particular formula and find out the diameter. Everyone should do that and find out the diameter. Yes, all of you please do the calculation and please tell me what is the diameter of the particular shaft. Yes, please. Yes, Tushar, Adesh, please tell me the value of diameter. Abhishek Kumar, Pansare, Vijay, Vedant, Vaishnavi, Tushar, Sneha Jadhav, Rutuja, Rohit. Please tell me the diameter value. Okay, Shivangini 77.76 mm. Okay, we will check it. Okay, next, anyone please post here the diameter you find. 78.26, 78.2. Okay, we'll cross check it. Okay, so diameter value is 78. Okay, so yes, it is correct. 78.26. Okay, 70 is correct, so it is a 80 mm. Okay, so those who are getting the 78 point something value, it is correct. Okay, so this type of a problem will be asked for 4 to 6 marks. Okay, simple problem. Okay, now we are going for the next problem, which will having 10 marks weightage. Okay, which is most important. Okay, so now I will just go ahead. Okay, here it is. Are you okay? Now is it visible that screen properly? Okay, such type of problems will be directly asked for 10 marks. Okay, it is very simple. Already you have learned all those things in engineering mechanics in first year. So it is the matter of only taking the movement, bending movement, all that thing. Otherwise, all procedure is remaining same. Whatever we are doing or the formulas are set. Okay, so already you have learned, so there is no need to worry about what is the complexity. Okay, so simple problem is there. Okay, just first we will go through the problem statement. Okay, a shaft which is supported by a two bearing placed at 1 meter apart. Okay, sometimes they will not provide you this diagram. In that case, you need to draw this diagram just by going through that particular problem statement. Okay, or sometimes directly they may give you. In that case you don't need to worry. Okay, but sometimes they will not give you. In that case you need to create that diagram as per the problem statement. Okay, now a shaft is supported by two bearings. Now here you can see A and B, these are the two bearings. Okay, the shaft total A and B is a shaft, and which is supported by bearing A and B. Okay, the left hand side and right hand side, that is shaft two bearings. Okay, a 600 mm diameter pulley okay, is mounted at a distance of 300 mm to the right of left hand bearing, and this drives the pulley directly below it with the help of belt having tension of 2.25 km. So त्यांनी सांगितलेलं आहे इथे 600 mm चा diameter असलेली पुली आहे, you can see here, and which is having distance 0.3 meter from the left hand side, okay, left hand bearing, okay, and with the help of belt having आणि which is having tension. इथं पण तुम्ही त्याचं राईट हँड साइड व्ह्यू बघू शकता. सी म्हणजे आउटर डायमीटर म्हणजे 600 एम एम ची पुली असलेली आउटर हे आहे बघा सी, ओके, विच इज हॅव्हिंग T1 अँड T2 टेन्शन, ओके. त्यातलं त्यांनी बेल्ट हॅव्हिंग मॅक्सिमम टेन्शन म्हणजे T1चं टेन्शन दिलंय 2.25 किलो न्यूटन, okay, okay. So another pulley 400 mm. Now D is the another pulley, okay, which is having 400 mm diameter. You can see 0.4 mm म्हणजे हा D जो दिसतोय which is of a 400 mm diameter, and it is placed 200 mm distance of the right hand bearing, and it is driven with the help of electrical motor. म्हणजे right hand bearing पासून is a distance 200 mm आहे, okay, and which is placed horizontally to the right, okay, which is placed horizontally to the right. That's why there will be the horizontal load on that particular pulley, that is on that D pulley, okay. So the angle of contact for both the pulleys 180 degree, and mu is equal to 0.20, that is coefficient of friction, mu is equal to 0.24. So determine the suitable diameter for a solid shaft. Now here you need to find out the आता याच्या आधीच्या प्रॉब्लेम मध्ये आपण पाहिलं होतं there was only one pulley, but here two pulleys are present, as well as one pulley is having vertical load acting, and one on one pulley the horizontal load is acting. So there is a combination vertical as well as horizontal load, and there is a two pulleys as well. So this type is a very important problem, and it may be directly asked for 10 marks from your NCM or as at the end of NCM. Okay, so such type of problems will be definitely will be asked. Okay, so today we will cover it, and I will give you 4 to 5 problems just like it. Okay, so I think I have already shared you RS Kurmi Gupta book. Okay, these problems I have taken it from the RS Kurmi Gupta book. Okay, so if you don't have, I will share it once again. Okay, and then you can also go through the RS Kurmi Gupta book as well. Okay, in that problems are very well explained as compared to VP Bhandari. Okay, the formulas are same in both books, only the notation is different. Okay, so you can either go through VP Bhandari book, or either you can go through RS Kurmi Gupta book. Already I have told you. Okay, so here you need to find out the diameter. So determine the suitable diameter and allowing working stress. Okay, the stress value they have given you in a tension, and shear stress value also they have given you 42 MPa in a tension. Okay, assume that the torque on one pulley is equal to torque on the other pulley. Here they have told you the torque on one pulley is same as the torque on the, म्हणजे C वरती जितका टॉर्क असणार आहे तितकाच D वरती असणार आहे. ओके, नाव आता हे जितकं दिलं त्याच्यावरून आपण गिवन डेटा बघूया. ऑल ऑफ यू आर यू गेटिंग दिस डायग्राम्स? हे समजलं का? शाफ्ट, टोन पुली आणि हे व्हर्टिकल हॉरिझॉन्टल फोर्स, आर यू गेटिंग दिस? प्लीज रिप्लाय so that we will go ahead. Yes, yes, Shoaib. Okay, fine. Yes, what about other student? Are you getting this? Yes, Akanksha Kadam, yes. Yes, Rutuja, okay, okay, fine, okay. So now just we'll go through the what is given data. Now given data, AB is equal to 1 meter. Now they have given you the distance from one bearing to another bearing is 1 meter. Okay. So DC, that is diameter of C pulley. DC is diameter of C pulley is equal to 600 mm. It is already given. And RC, the radius of C pulley is 300 mm, which is 0.3 meter. Okay. Now then AC is distance A from bearing to the C pulley is 300 mm, 0.3 meter. Where T1, already I have told you on that T1 they have given you 2.25 kilonewton, so which is of 2250 newton. Okay. Then DD is the diameter of D pulley, okay, which is of 400 mm. So that's why radius of D, that is D pulley, is 200 mm, which is zero point 0.2 meter. Okay. Now BD is the distance. B to D distance is zero point 0.2 meter, that is 200 mm. Then theta is 180 degree. So here you can see theta is equal to 180 degree. Just okay. and pi radian, okay, that mu is equal to 0.24, okay, and bending that 63 MPa, that is they have given you here the working stress, allowable working stress, okay, that's why 63 MPa, 63 Newton per mm square, and tau, that is shear stress is 42 MPa, okay, 42 Newton per MPa, mm square, that is given, okay. Okay, so should we go ahead? Okay, now here is T1 is what? Okay, here you can see the diagram. Okay, so in that case, T1 is equal to tension in the tight side of the belt on a pulley, and it is given 2250. Okay, 2250 Newton. T2 is what? Tension in the slack slide of the belt pulley on pulley C. Okay, ही diagram मी already तुम्हाला दाखवले C आणि D pulley. On C pulley there is a vertical load acting. On D pulley there is a horizontal load acting. That is T1, T2 आणि इथे आपण इंडिकेट केले T3, T4. ओके, याच्यात T1, T2 मध्ये T1 हा टाइट स्लाइड आहे आणि T3, T4 मध्ये T3 ही टाइट स्लाइड आहे. Okay, so T1 upon T2, now this is the most important formula. T1 upon T2 is equal to e raised to mu theta, because they have given you coefficient of friction and the theta value angle. Okay, so T1 upon T2, okay, just do that. E raised to mu is दिलेला आहे मला वाटते 0.5, how much given mu 0.24, okay, and e raised to mu theta is 180 degree, we have to take it in a pi radian, okay, so mu is equal to 0.24 and pi radian, so just now do the calculation. T1 upon T2 is equal to e raised to mu theta, so T1 upon T2 is equal to 2.127. Once I will put e into mu theta, I will get 2.127. Okay, so T2 is equal to T1 upon 2.127. Okay, already we know about value T1. So 2250 upon 2.127, which is equal to 1058 Newton. That is T2. Means the tension in the slack slide is 1058 Newton. Because already we know the tension in the tight side is 250 Newton. Okay, all of you, are you getting this? Yes, please tell me if you're not getting, otherwise there is a uh, complexity. Please tell me if you are getting it or not. Yes, Rutuja, yes, fine. Adesh Patne, yes. Vaibhav Kulkar, yes. Vijay Sawan, yes. Okay. Shoaib, yes, fine. Soham, yes. Yes, Saurav, yes, fine. Okay, you are getting it. It's very good. Okay. So yes, Rushikesh, yes. Okay. So here first we are going to find out the tension in that particular that belt. Okay. In earlier problem already they have given you T1 and T2. तुम्हाला T1 and T2 दिला होता. So directly आपण find out करू शकत होतो load on that particular pulley. That is addition of T1 and T2. But here they have given you only T1 value. So here your task is to find out T2. Now can you find out vertical load which is acting on the shaft at C? Just find out vertical load now acting on that particular shaft at C. What will be the formula? How to find out vertical load on that C pulley? Just you can unmute and you can tell, or just you can put it over here. Just you can unmute. How to find out now vertical load on shaft at particular at C point, at C pulley. Earlier मगाशी आपण फाइंड आउट केलं होतं पुलीवरती येणारा लोड. Yes, how to find out? Yes, exactly. Sachin Panse, it is correct. It is the addition of tight slide and slack slide. So total vertical load WC, okay, that load which is acting on a C pulley is equal to T1 plus T2. So T1 आपल्याला माहिती आहे 2250, T2 आपल्याला माहिती आहे 1058. So total load acting on a shaft at a C is 3308 Newton. Yes, it is correct. Vaishnavi, Sachin, it is correct. Very good. Now the vertical load on the shaft at D is equal to 0. Why? Because on pulley D there is a horizontal load acting. So here इथे vertical चा काही मग विषयच आहे. So the vertical load on shaft at D is 0. Are you getting it? So because on D pulley there is a horizontal load. On a pulley C there is a vertical load. That's why on D there is a no any horizontal load. Okay, so it is 0. Now T3. So now how to find out the torque on that particular shaft? T is equal to मगाशीच आपण formula पाहिला. T is equal to T1 minus T2 into radius of C pulley. Okay, so T1 is 2250 T2 is 1058 into radius of C pulley is zero point 0.3. So that's why 357.6 Newton meter will be your torque. Okay, torque which is transmitted by the shaft or which is acting on the C. And already in problem statement they have given you the torque which is acting on a C pulley and D pulley is C. So here we have find out the torque which is acting on a C pulley, so that will be the same for the D pulley as per the problem statement. म्हणजे डी पुलीवरती पण टॉर्क किती ऍक्ट होणार आहे, इतकाच होणार आहे, 357.6 न्यूटन मीटर. Okay. Now, T3 is what? The tension in the tight side of the belt pulley at the point D, and T4 is the tension in the slack side. So T3 and T4 is tight and slack side for that particular D pulley. Okay. So now since the torque on the both pulleys, that is C and D, is same, therefore T3 minus T4 into radius of a D, that is a D pulley, which is equal to T. So सेम असणार आहे, म्हणजे हा जो फॉर्म्युला आपण मॉडिफाय केला तर इथली टी व्हॅल्यू इथे सेम राहणार आहे, 357.6 न्यूटन मीटर. सो नाव T3 minus T4 is equal to काय होणार आहे, 357.6 divided by RD. म्हणजे हे मी इक्वेशन काय केलं, मॉडिफाय केलं. आर यू गेटिंग दिस? सो T3 minus T4 is equal to 357.6 divided by RD. Here's equation we modify केलं. So radius of a D, that we already know, radius of a D pulley. So here I will get T3 minus T4 is equal to 1788 Newton. आता आपल्याला T3 पण माहित नाही, T4 पण माहित नाही. आता आपल्याला दोन्ही फाइंड आउट करायचे, त्याच्याशिवाय आपण D वरती किती लोड ऍक्ट होते आपण फाइंड आउट करू शकत नाही. So here is our task is to find out T3 and T4. Okay, how much will be the load on that particular T. So T3 upon T4, जसं इथं T1 upon T2 होतं, तसं इथं T1 upon T2 is equal to T3 upon T4 is equal to 2.127. कारण T3 upon T4 is equal to आपण काय करणार आहोत, पुन्हा e raised to mu theta. पण e raised to mu theta किती येतंय, 2.127. That's why T1 upon T2 is equal to T3 upon T4 is equal to 2.127. Okay, or T3, just I will modify, T3 is equal to 2.127 into T4. So now I will put that T3 here in this equation. Okay, so that I will get 2.127 T4 minus T4 is equal to 1780. Now just find out T3 and T4 value. Now your task is to find out T3 and T4. Now just put that T3 over here and just find out T3 and T4. Just do it fast. We have to finish this problem in today's session. Okay, just find out T3 and T4. Yes, please do it fast. Find out T3 and T4. Just you have to put that T3 over here in this equation. Directly you will get T3 and T4 value. Just find out fast. Please do it fast. Okay, T3 is 3377. And what about T4? Or you can unmute and just take, okay, Alpha T3 is 3374, T4 is 148. Okay, we will check. Here it is. T3 is 3376 Newton and T4 is 1588 Newton. Okay, so it is correct. Yes, Shivangini Alpha, it is correct. Everyone should do that calculation. Okay, it is very important one. This problem is very important one. Such type of a problem will be directly asked for 10 minutes. Okay. Okay, now can you just tell me horizontal load which is acting on the shaft at D? So what will be the equation again? Now horizontal load acting on the shaft is T3 plus T4. Now it is the addition of T3 plus T4. Just find out how much will be the load acting on the pulley D. So WD, that is load acting on the D pulley, is equal to T3 plus T4. जसं आपण मगाशी केलं same. Load acting on the C pulley is T1 plus T2. Now load acting on the D pulley is T3 plus T4 is equal to Addition of these two, 3376 plus 1488, so which is 4964 Newton. Okay. Now here horizontal load on the shaft C. Okay, on the shaft at a C pulley is 0. जसं की मागाच्या केसमध्ये horizontal load on a pulley C is 0, तसं vertical load on a pulley D is 0. Okay, so the horizontal load on the shaft C is 0. Okay, all of you, are you got this up till this? Should we go ahead? Yes, please, from your side. Yes, okay. So we will go ahead. Adesh, yes, Sachin, Adesh. Okay, it is fine. So here, first we have find out how much is the load which is acting on a C pulley and how much is the load which is acting on a D pulley. So this is the first step. Okay. So first we need to find out the how much is the load. Okay. So here is the most important formula, T1 upon T2 is equal to E raised to mu theta. आणि इथे आपण टॉर्क पण फाइंड आउट केलाय. How much will be the torque transmitted by the particular shaft on that particular C and particular D pulley. So T is equal to T1 minus T2 into RC. Okay, so just like this. Now the next. Now we will find the maximum bending moment for vertical and horizontal loading. Now here we need to find out the maximum bending moment for vertical and horizontal loading. कारण आपल्यावरती C पुलीवरती vertical load आहे आणि D पुलीवरती horizontal load आहे. So here I have drawn the vertical load diagram. Here you can see now C is having vertical load and D is having horizontal load. So first we will go for the C pulley which is having vertical load. Okay. So first of all we will consider the vertical loading at C. Now C वरती आपला लोड किती आहे 3308 न्यूटन जो की आता आपण मगाशी फाइंड आउट केला. ओके वर्टिकल लोड दॅट इज ॲडिशन ऑफ T1 प्लस T2. सो नाव आता D वरती काय असणार आहे 0. Why 0? Because C pulley is under vertical load tension. Because that's why, and D is under horizontal load application. That's why on D there is a 0 load. Okay, because it is a vertical load diagram. Okay, so first we'll go for the vertical load diagram and then we'll go for the horizontal load diagram. Okay, and bearing A and bearing B, that's why reaction RAB, that is vertical reaction at A and vertical reaction at B. Okay, so are you getting this FBD for the vertical load diagram? Then we'll go ahead. Okay, so this is the vertical load diagram because vertical load which is acting at a point C. Here you can see the outer pulley C pulley. The vertical load is on that C pulley which is of 3308 Newton. Already we have found out. The RAB and RBB are the reactions and the bearings A and B respectively. Okay, so D there will be the zero load because D pulley is acting for the horizontal load direction. Okay. So we know that now RAB plus RBB, they are going vertically upward and that load which is vertically downward. That's why RAB plus RBB is equal to 3308 Newton. Okay, so all of you, are you agree with this? Okay, now taking moment about A. Now just all of you find out, just take the moment about A and find out RBB and RAB. Everyone should do that. Just take the moment about A and just find out the distance is given. It is of how much is the distance AC. Have you drawn the diagram first one? Please find out RAB and RBB. Can you find out taking RAB and RBB value? Yes, please. Okay, RBB is 992.4. Akanksha, okay, we will check it. And what about RAB? Everyone, please do that calculation. If you not do that calculation, then otherwise you will not get idea about how to calculate. Just seeing, okay, बघितल्यानंतर सगळं दाखवल्यानंतर इथे बरोबर वाटतं हा it is correct. But when you are going to solve, you may get trouble. So everyone should solve this problem in a lecture. Okay, just try to solve in a lecture so that you will that practice solving problem. You will get practiced. सगळ्यांनी सॉल्व्ह करण्याचा प्रयत्न करा. इथे शिकवताना समजतं पण जेव्हा ऍक्च्युअल सॉल्व्ह करायला असतो तेव्हा आपल्याला नाही सॉल्व्ह करतात. सो एव्हरीवन शुड डू प्रॅक्टिस. Okay, Shivani, Sneha, they are replying. Okay, we'll check it. So RBB, okay, into 1 is equal to 3308 into, okay, just by taking the moment. So RBB is 992. RBB is 992.4. Yes, Akanksha Kadam, your answer is correct. So RAV, I think remaining student they have found out about RAV. So RAV is 231.56 Newton. So it is correct. All of you find out values are correct. RBB is 992.4 and RAV is because you can just put RBB over here and you can find out RAV. So it is 231.56 Newton. It is correct. Okay. Now we know that bending moment at A and B. Now we need to find out now what is the bending moment at A and B? It is zero. Okay. So bending moment at A and B is zero. So we need to take the bending moment at C and D because C and D there are pull. Here are the bearings. So there will be bending moment at A and B is zero. Okay, so that is MAV, that is bending moment at A in vertical direction and moment at B in vertical direction is zero. Okay, so MAV and MBV is equal to zero. Now bending moment at C, we will find out bending moment at C and bending moment at D. Okay, so that bending moment at C is nothing but 3308 into this distance. Okay, like this. MCV is equal to RAV into zero point 0.3. Okay, so that RAV into because we are taking bending moment at C, so that is RAV into zero point 0.3. So RAV already we know 231.56 into zero point 0.3. So here you will get bending moment at C in a vertical direction is 694.7 Newton meter. Just like now we will take bending moment at D, okay, which is nothing but RBV into this distance, okay. So MBV is equal to RBV into zero point 0.2. This distance is zero point 0.2. So it is in a meter. That's why here we have taken it in meter. So 992, okay, RBV is 992.4 into zero point 0.2. So that's why bending moment at D is equal to 198.5 Newton meter. Okay, so this is about the movement at A. By taking movement at A we have find out RAV and RBV, and just by taking movement bending movement at A, B, C, D, we have find out the bending movement at C, bending movement at D, and bending movement at A and B is 0. Okay, so this is about the vertical load diagram. Now just similar we will do for the horizontal load diagram because on the pulley there is a horizontal load. Okay, are you getting this? Should we go ahead? The last part of the problem, okay, that is horizontal load diagram and finding out the diameter. Okay, should we go ahead? Yes. Okay, so up till this it is fine. Okay. Okay. Okay, now here is the horizontal load diagram. Okay, same A, B, C, D, C. Okay, now there is a horizontal load कुठल्या पुलीवरती ऍक्ट होत होता डी पुलीवरती आणि जो आपण फाइंड आउट केलाय विच इज T3 प्लस T4 सो विच इज ऑफ 4964 न्यूटन. नाउ सी पुलीवरती हॉरिझॉन्टल लोड आहे का नाही सी पुलीवरती वर्टिकल लोड होता दॅट्स वाय ऑन सी पुली देर इज अ झिरो लोड. Okay, and RAH and RBH. Now here is reaction at A in horizontal direction and reaction at B in horizontal direction. So here is the bending moment diagram for horizontal loading. Now considering horizontal load at D, okay, RAH and RBH with the reactions at the bearing A and B, okay, respectively. So we know that so RAH plus RBH is equal to 4964 Newton because RAH and RBH is going in vertical direction and 4964 that is load which is acting on the D pulley is going in downward direction. So positive, negative, that's why RAH plus RBH is equal to 4964 Newton. Now just take the moment about it and just find out RAH and RBH. All of you please find out. Yes, do it fast. This is the last point of this problem. Just find out RH and RBH now. Okay, RBH Akanksha 3971. Okay, what about RAH? Everyone should do that. Okay, RBH. Okay, Shivangini 3. Okay, you are getting same answer. Alfia, Sai Ganesh. Okay, you are getting same answer. Just will cross check it. Okay, so RBH is equal to 3971. It is correct. Yes, you got the correct answer. And then RAH is 993 Newton. Yes, it is correct. Okay, so all of you are doing it. It's very good, and you are getting the correct answer. Okay, so this is about RAH and RBH. Okay, now we know that the bending moment at A and B is what? Zero. Again, जसं की मागाच्या केसमध्ये bending moment at A in horizontal direction and bending moment at B in horizontal direction is zero. Now your task is to find out bending moment at C and bending moment at D in horizontal direction. Okay, now bending moment at C RH into this distance and bending moment at D RBH into this distance. Okay. So first we will find out bending moment at C, which is MCH, bending moment at C in horizontal direction is equal to RH into zero point 0.3. This distance is zero point 0.3. So RH we already find out 993 into zero point 0.3, which is equal to 297.9 Newton meter. Now bending moment at D, so RBH into this distance, which is of 0.2. So 397 RBH is 3971 into zero point 0.2, which is equal to 794.2 Newton meter. Okay, so this is about the bending moment at C and D in case of a horizontal direction. Okay, so all of you, are you get this up till this? The same procedure for vertical diagram and for horizontal diagram. So the main task in these two, you need to draw the correct FBD diagram. If you draw the wrong FBD diagram, then your answer may get wrong. Okay, so it is very simple one. Drawing the FBD diagram is again very simple one. Okay, just you have to put whatever the values you are getting, just you have to put it in a schematic view. Okay, now we need to find out the resultant bending moment now at C. Now, how to find out resultant bending moment at C? So, moment at C is equal to square root of moment at C in vertical direction square plus moment at C in horizontal direction. So, मगाशी आपण vertical direction मध्ये काढलेला आहे bending moment at C आणि आता इथे MCH. Okay, हा जो काढलेला आहे. So, square of these two terms and you will get the resultant bending moment at C is 756 Newton meter. Now, how will you find out the resultant? Just find out now resultant bending moment at D now. What will be the formula now? MD is equal to now MCH bracket square plus M dV square plus MDH square. Okay. So here task is to find out the resultant bending moment. So this formula you have to reach vertical direction plus horizontal direction, then the square and that's a square. Okay, so here we will get MD is equal to, that is bending moment, resultant bending moment at the pulley is 819.2 Newton meter. And resultant bending moment at C is, everyone should note down these formulas. Okay, this is the most important formula to find out resultant bending moment. Okay, so which one is the resultant bending moment is greater value? Either on C pulley or D pulley. कुठल्या पुलीवरती जास्त bending moment आहे? Yes, please. Okay, here if you see the diagram or if you see the calculation, bending moment, resultant bending moment at D is 819.1. Yes, yes, most of the students are, yes, Pallavi, Sachin, Akash, yes, it's correct, D pulley. Why? Because the value we are getting, resultant bending value we are getting is greater than the moment value which is at the C pulley. That's why the bending moment is maximum at a D pulley. Okay, so now we will go ahead. Now we will take this bending moment value for the further calculation because the bending moment value is greater in a deep. Okay. Okay. Now we see that the bending moment is maximum at D. So म्हणून maximum bending moment, that is M is equal to MD is equal to 819.2 Newton meter. Okay. Now our task is to find out diameter of the shaft, that is small t. Okay, so we know that the equivalent distinct moment, that is TE is equal to, already we know that formula, m square plus t square. Okay, now m we know the value, torque already we have find out. Okay, already आपण torque find out केलेला आहे. Okay, so just it is a square of m square plus t square. जसं की आपण मगाशी find out torque केल्याप्रमाणे इथे आपण put up केला. So here we will get the t equivalent value as a 894 into 10 raised to 3 Newton m. So this is the equivalent twisting moment or equivalent torque moment. Okay, now we also know that equivalent twisting moment, this is the formula. T is equal to pi by 16 into tau into T. Okay, it's a formula पहिला. Okay, once you will put all those values here, what you will get, diameter is 47.6 mm. Okay, so this is based on the equivalent twisting moment value. Okay, now same we will do for the equivalent bending moment. So first we will find out what is the formula to find out equivalent bending moment. Here it is. हा फॉर्म्युला पण ऑलरेडी बघितलेला आहे. mb plus square root of m square plus t square किंवा mb square plus mt square. These notations are from MB Bhandari book and these notations are from the RS Purni book. Okay, so me is the equivalent bending moment, t is the equivalent twisting moment. सो आपण इक्विव्हॅलंट ट्विस्टिंग मुवमेंटला डायमीटर फाइंड आउट केलं. आता इक्विव्हॅलंट बेंडिंग मुवमेंटला आपण डायमीटर फाइंड आउट करणार आहोत. जी व्हॅल्यू लार्जर असेल ते आपण कन्सिडर करणार आहोत. ओके. Okay, now here MB is nothing but M plus now this MB square plus MT square is nothing but what? Equivalent torque. So I will put all the value, M value 819.2 and equivalent torque is 894. Okay. So what I will get, any equivalent bending moment value is 1713.2 Newton meter. Okay. Now here we are taken it in Newton meter, we will convert it into Newton mm so that we will get the diameter mm. Okay. Now your next formula, that is sigma 1 upon 16 upon pi d cube, that is stress value. Sigma 1 is nothing but normal stress value and it is already given in the problem statement. So which is based on the bending moment formula. Okay, that is principal stress theory formula. 16 upon pi d cube into that is me. Okay, this formula is nothing but equivalent bending moment. So I will put all the value, that is normal stress value they have given you 63. Now I will put all the value mb plus that is m equivalent. Here I will put all that 1713.2 into 10 raised to 3. Okay, just find out the diameter value now. Okay, today's lecture is we are taking too much time because the problem is quite lengthy one. Okay, we will wind up in 2 minutes. Can you find out diameter now value by just putting all that? Okay, just we can do it and cross check. Now here we are getting d is equal to 51.7 mm. Now taking the larger value of the two values, which one is the larger? According to the equivalent twisting moment, we are getting 47.6, and according to the equivalent bending moment, we are getting 51.7 mm. So we need to take the larger values of the two. So we will take 51.7 or say 55 mm. This is the diameter for that particular shaft when vertical and horizontal load which is acting on that particular shaft. Okay, so all of you, are you got this problem? Yes, 51.74. Yes, Neha Jadhav, it is correct. So 51.7, so it is 55 mm. Okay, so it is greater than the twisting, equivalent twisting moment diameter. So you need to consider this diameter for that particular shaft. Okay, all of you, are you got this problem? Yes, please.